Hey everyone, welcome to Code Harmony. Today we are going to solve this LeetCode challenge 2017 grid game. This question has asked in Amazon and it is based out of prefix sum concept. Let's understand the problem statement with example. What is given to us? We are given a grid. What is the size of the grid? 2 cross n. Okay, and what is the operation? Operation is that we are having two robots, robot 1 and robot 2. Robot 1 and 2 both are going to iterate over this grid from index left top to right bottom, and they have two directions to go. Either they can go to the right direction or they can go to the down direction, right or bottom. Only two directions are there. We are going to start with robot 1, and robot 1 is going to start from left top and it has to reach to right bottom. Whatever path it want to choose, it can choose, and then whatever value it is encountering, it is going to capture that points, going to utilize those points and leaving 0 at that position. So if robot 1 is following that route, the grid will look like this: 0 0 4 1 5 0. Okay, this is the route. No, this should also be 0 0 0 4 1 0 0. This will the grid look like once the robot 1 has done its work. Now the robot 2 will come into picture, and robot 2 will also go from left top to right bottom in a way so that it can achieve the maximum score. And the tendency of the robot 1 is that it want to minimize the point captured by R2, and robot 2 is always try to maximize the point by R2. Robot 2 is trying to maximize its points, and robot 1 has a tendency to minimize the profit of robot 2. In the end, what we have to return is points collected by robot 2. Now you can have a look on the problem statement. Let's read this paragraph. We are given a grid of size 2 cross n, and two robots are playing the game. What they are doing, both robots will start from 0 0 and they have to reach 1 comma n minus 1, and these are the two directions, right or down. What is the next paragraph? At the start of the game, first robot is going to move from this position to this position. It means the first robot is going to start the game and collecting all the points from the cell on its path. And if the robot is collecting points from this cell, the cell value will become 0. And then the second robot will move from the same left top to right bottom, and whatever point it can collect, it will try to collect. In the end, the first robot have a tendency to minimize the number of points collected by second robot, and the second robot will always try to maximize the point collected by it. And we can assume that both the robots are playing optimally, and in the end return the number of points collected by the second robot. So this is the problem statement. Now what they are trying to say is, initially robot 1 will start its journey, then robot 2 will start its journey, and both are starting their journey from 0 0 and they are going to reach 1 comma n minus 1. So let's say the robot 1 has followed this path 1 3 1 3 1. Let's say this path the robot 1 is following. If the robot 1 has followed this path, the grid state will look like this. All the grid cells on this path will become 0 and the remaining will be same. Okay, now this is the grid state, and robot 1 work is done. Now the robot 2 will come into picture, and robot 2 will try to grab the maximum point as it want to achieve. And what are the directions we are having? We are having only two directions: either go to the right side or go to the down side. Let's say the robot is moving in the right side, and it keeps on moving the right side, and then it make a turn to the lower side. And after this position, after this turn, it has only one direction to go, straight. So the path will always look like this, going in the straight line and then making a turn and again going in the straight line. Similar to this case, going straight line and then making a turn, then straight line. So what this situation is saying, that the robot 2 have only these much possibility. Either the robot 2 is going to follow this path, or the other possibility is robot 2 is following this path. The yellow and green is the two possibilities for robot 2. Either making turn on the index 0 or making turn at index n minus 1. Okay, so these two possibilities are left with robot 2 to grab the score. And the robot 2 has a tendency to maximize its score. If the robot 2 want to maximize its score, so it has only these cells, these non-empty cells, these are non-empty cells. If the robot 2 is following the yellow path, then 1 plus 3. If the robot is following the green path, then 15. 15 is the answer and 4 is the answer. Whatever is the maximum, we are definitely going to choose the maximum. So we will choose 15. If I is 2, if I is 2, then 15 is the answer for robot 2. But our tendency is, in short, robot 1 tendency is to minimize this maximum value. So now in this case, what is the maximum value? Maximum value is 15 at I equal to 2. And now we want to minimize this maximum value. What is this maximum value? Sum of items from second row before the turn and sum of items from first row after the turn. So these two possibilities are for robot 2, and whatever is the maximum, we are going to pick that for the specific index I, and among these maximum values we want to choose the minimum one. Okay, because robot 1 is starting and robot 1 is doing the game optimally, so it will make the turn according to the case that robot 2 is going to get the minimum sum. Now if we try to build the approach, we have this possibility, this is the grid given to us, and let's say the robot 1 is making turn at ith index. Let's say this is the ith index. It means till this moment it is going to collect all the points, and then during the turn going to collect all the points. This case going to collect all the points. So these all values will become 0, and we are left with two possibilities. Either the robot 2 can pick these two, or robot 2 can pick this one. So from this situation, either this suffix is one possibility for R2, or this prefix is one possibility for R2 sum. So whatever is the maximum, we are going to pick, and from those maximums I'm going to pick the minimum. So how do I find this value and this value? And this is my ith index, and this ith index is going from 0 to n minus 1. Let's say somehow I capture all the values sum in the first row. Sum of row 0. Let's say I have sum of all the elements from row 0. Now this I am having, and I am iterating using I from 0 to n minus 1. Let's say this case 1, 2, 3, 4, 5, 6, I equal to 0. For I equal to 0, I want sum of these two elements, and from this case left side there is nothing. It means this is the for loop. Okay, now I want this prefix as well. This suffix I already know. Sum row 0 is going to give me the suffix. And how I'm going to get the suffix? From the sum of row 0, if I keep on deleting the ith item. So sum row 0 minus ith item, this is going to be my suffix. And what is the prefix? Prefix is sum of row 1. This is my prefix, and I'm going to capture the prefix in the end of this iteration, because currently I don't want the prefix. Now what is our aim? Our aim is to minimize the maximum sum of R2. So if we have to minimize, just take the minimum operator. Sum of R2 is answer. So just minimize the answer. And what is the answer? This suffix plus prefix. So suffix or plus prefix. Maximum of suffix and prefix. And what is the suffix? The maximum of suffix is sum from row 0. And what is prefix? sum from row 1. And now after this I need to update the sum of row 1 as well. Sum of row 1 plus equal to ith item. This is our whole logic. First thing, prepare the suffix. Second thing is capture the minimum value of my R2 sum. So this value is going to give me R2 sum. And the third one is update the prefix. So for any moment, let's say 1 2 3 4 1 2 3 4, if this is my I, this is going to be my suffix, this is going to be my prefix, and the maximum of these two is my R2. R2 means robot 2 points what robot 2 is getting. Okay, so this is my algorithm. And how much time it is taking? It is going to take order of n time, because first of all it is capturing sum of all the elements in the first row and then going one more iteration of n time. Grid is of size 2 cross n. Ignore the 2. Time complexity is order of n. And what about the space complexity? Getting a variable to capture the sum of first row and then one more variable to capture the sum of row 2. So it is a constant space solution. Constant space and linear time. Now let's code this approach. I have taken the length of the row, and the row 0 is going to take a sum of all the elements in the row 1, and now I want to iterate over the row again with I index for I equal to 0, I less than n, I plus plus. This is my ith index, and for ith index, see, let's take a variable long, let's say answer. Answer is going to be the minimum sum of R2. So for that, integer dot max value, not integer, long dot max value, and this is going to be my answer. Okay, now what I require is row 0, suffix part from the row 0, prefix part from the row 1. For row 1 also, row 1 is equal to 0, and row 0 minus equal to grid of 0 and then I. So now my suffix is ready. And what about the prefix? Prefix is already ready because I is starting with 0 and the previous elements are already captured. And what I have to do is, this answer is going to be math dot minimum of this answer and the other part. And what is the other part then? Answer, sum of points captured by the robot 2 should be maximum. So math dot maximum. Either the robot 2 can pick these points, the suffix which is row 0 or the row 1. And the row 1 is going to have all the elements prior to transition index. So row 1 is going to be plus equal to grid of first row and then ith item. This is suffix and this is prefix. Whatever is the maximum, just capture the minimum of those maximum values. Yeah, this much we have to do. Let me test our sample test cases. Sample test cases are passed. I'm submitting the problem. Submitted successfully. I hope you have understood the approach. If you get any doubt, you just comment down below. I will be happy to help. Thank you guys. Bye bye.